Hello and welcome everyone to non-IITian. This is a problem in real analysis which is from TIFR GS PhD 2024. I guess it was integrated PhD. They have the same exam though. Okay. So, and the problem is related to the countability of a function's support. Okay. If you enjoy the content, please don't forget to like, share and subscribe. Let us see the problem statement. So the problem statement is as follows. Let f be a function, a non-negative function on the real numbers, such that for any finite set E in R, the summation of f over all the elements, the images of all the elements over the finite set, is less than or equals to 1. Now we are given a set CF which is defined to be the collection of all those real numbers such that the image of all those real numbers under f is greater than 0. So this set is actually what we call the support of the function. Okay, this set is what we call the support of the function. Now the question was, then which of the following statements was true? Firstly, that CF is a finite set, CF is a bounded subset of R, CF has at most one limit point, and CF is a countable set. Now the questions in TIFR are all MCQ type, only one options are correct, and the correct option to this is D. Now the solution to this, I won't be saying it's difficult, but it was again based on a very tricky observation which was sort of coming from Archimedean principle of the real numbers. Let's see. So we'll prove that the option D is the correct option, that is CF is actually countable. Okay, let's see. So to prove that CF is countable, let's define a set AN which is defined as follows. So AN is equals to the collection of all those real numbers such that the image of those real numbers under f is greater than 1 over n. Okay, is it clear? Fine. Now we claim the following, that CF is actually the union of all these ANs. Okay, now why is it so? Observe that if I choose x from AN, or let's say union AN, then that implies that x belongs to AN for some n, right? And then that implies that f of x is greater than 1 over n, which is obviously greater than 0. So this implies that x belongs to CF, right? So therefore the union is contained in CF. That's clear. What can we say about the other inequality? Now the other inequality is what we can get hold of from the Archimedean principle. Observe that if I choose x from CF, then that implies f of x is greater than 0. But then by Archimedean principle, which implies by the Archimedean property of R, there exists some natural number such that f of x is greater than 1 over n. What does this imply? So I'm just writing it here. So this implies that x is in AN for some n, and this implies that my CF is also contained in the union of ANs, right? So we can prove this claim quite easily, as we can see. Fine. Okay, so now this is a countable union, right? So what we have proved up till now is that CF is a countable union, and we obviously claim that CF itself is countable. For that, I can at most try to prove that AN is countable, because we know that a countable union of countable sets is countable. But in fact, we will be able to prove that each AN is not just countable, but rather it's finite. Okay, let's see. Okay, so let E be a finite subset of AN. E be any finite subset of AN. Then by the definition of AN, for each xi in E, we know that f of xi is greater than 1 over n. Therefore the sum of fxi's, I ranging from 1 to k, that is the images of all the elements from the finite set, that is greater than summation I is equals to 1 to n of 1 over n, which is k over n. Clear? Fine. But from the problem statement, what do we know? That the summation of I is equals to 1 to k of f of xi is less than or equal to 1. Why is it so? As E is a finite set. As E is a finite set. Hence, we have k over n is less than summation I is equals to 1 to k f of xi, which is less than or equal to 1, which implies that my k over n must be less than 1 or k must be less than n. Is it clear? Is it clear? So therefore, what can we conclude from here is that I can have at most n minus 1 elements in an, right? I can have at most n minus 1 elements in an, and hence an is finite. Otherwise, what will happen is that when I take the sum f of xi, this will become n by n, or rather it will be greater than n by n, which is 1 once I exceed n minus 1 elements. Getting my point? Clear? Okay. So thus the countable union of countable sets is always countable, and hence we prove that CF is actually a countable set. Is it clear? Got it? So therefore, let us get back to the option. So we have proved that option D is the right option. Please do like, share and subscribe if you like this video. Meet you guys soon.